All right, welcome. This is 6.3, writing equations from word problems, okay? So let's just get into this. It says application problems. Remember to start by drawing a picture, making all important parts of the graph, okay? So I require that you draw a picture of what's going on, including the points that they include, and I'll give you an example of that. So Sean is kicking a soccer ball to his dad, okay? So here's Sean. Has a ball, kicking it to his dad, okay, who's 10 meters away. So we want to come up with some sort of axis. So this would be 10, and this would be height, okay. Y would be height, distance would be x, okay. And then it says after 2 meters, the ball is 1 meter in the air. So we'd want to come some sort of point here, would be 2 meters, it is 1 meter in the air, okay? Sorry, my person's in the way, but I think you got it, okay? So that gives us a parabola, something like that. It doesn't have to be perfect, okay? You just need to label the points, okay? So, and then it says write an equation that represents the path of the ball, okay? So after you've got your picture, you're going to want to write down, they're always going to give you one of the key features, specifically either the vertex or the two x-intercepts, okay? So we're going to always want to look for that, and then there's always going to be one point. So this is just like we did in 6.2, where I gave you the x-intercepts and I gave you a point and you came up with the equation, or I gave you the vertex and a point and you would come up with your equation. So basically we're taking this word problem, we're going to find that information, and then we're going to do the exact same thing we did in 6.2. So here, looking at this, we don't have the vertex. The vertex would be here. We don't have any information about the vertex. All we know about the vertex is it's halfway between the son and the dad, okay? We don't know the height at that point. All right, but we do have where it started, 0, 0, and we have a point at 10, 0. And those would be your zeros, or your x-intercepts. Okay, so just like we did before in 6.2, if we have the x-intercepts, then we're going to want to use intercept form, which is y equals a, x minus p, and x minus q. All right, and we also need to have, we don't know what the vertex is, but we need a point. Okay, and we can't use the same points that we used for the x-intercepts, but they do give us a point of 2, 0, or 2, 1, sorry, 2, 1. Okay, and that's where the ball is. 2 meters after he kicked the ball, it's 1 meter in the air. Okay, so if we want to label those, just like we did before, this would be our P, this could be our Q, and this would be an X and a Y. Plug all that information in. So after this, it's all just review what we did last time. So Y is 1 equals A, X is 2 minus P, which is 0, and then we'll do X, which is 2, minus 10, which is our Q. Okay, simplify, that gives us 2 times negative 8. That gives us negative 16. And then we'll end up getting A, divide both sides by negative 16. Cancels, we get A is negative 1/16. Okay, so now we have our A, we have our P and Q. We'll write our equation. Y equals negative 1/16. X minus 0, well, that's just X. So simplify that. Don't leave zeros in there. X minus 0 is X. And then we'd have X minus 10. Okay? All right, so let's try another one. It says, May hits a softball so that its maximum height is 60 feet at 3 seconds after she hits it. Okay? So we want to come up with May. Okay? And the ball at some point is, after 3 seconds, the ball is 60 feet in the air. all right? Then it says, if she hits the ball 3.5 feet above the ground, so she started, hit the ball, like right here, this would be 3.5 feet. This would be time of 0. What is the path of the ball in seconds? So here we'd have her hit the ball. Actually, I didn't do that very good. To kind of make it look like it's a parabola, okay? And it comes and hits. So what is the key feature that they're giving? Did they give us the zeros, the x-intercepts, or did they give us the vertex? So here you'd probably realize that it's a vertex. Whenever this is kind of a key word, if they say maximum or minimum, those would be that would be your vertex. So our vertex here is 3, 60, and then we also need a point. Okay, so the point here would probably, I guess the only other choice would be 0, 3.5. Okay? And then we're going to label those. So this would be like our x and our y. Vertex is h and k. So we have y is equal to ax minus h squared plus k. So we'll plug in all that information. We'll get 3.5 is equal to a. That's what we're going to solve for. X is 0 minus h, which is 3, plus k, which is 60. Okay, and then we just need to solve for a. All right, this part, that gives us -3, and -3 squared is 9. Okay, let's subtract 60 from both sides. All right, and that gives you -56.5. And then we'll divide both sides by 9. Okay? And we end up getting that. Most likely, you will want to have your answer as not having decimals. Okay? So if you wanted to make that right as a whole number, we just need to multiply top and bottom to get no decimals. Okay? Oftentimes calculators will do that too, even on a TI. So if you turn on a TI and you go -56.5 and divide it by 9, it will give you a decimal, but if you click on math, it's like on the left side, right underneath the green button, it says math. The thing at the very top is frac, so push enter, and push enter one more time, and it will give you a fraction. So that ends up giving us a equals -113/18. So all they did was multiply top and bottom by 2 to get rid of that decimal. Okay, so we get our a. We have our a, h, and k. So our equation will be y equals -113/18 x minus 3 squared plus 60. Okay, and we'll do one more. Okay, I crossed off some of the stuff on yours just because I think it was a little confusing. So it says Alex is kicking a field goal. If the ball landed 30 or 22 yards away, what is the equation for the path of the ball if the maximum height of the ball is 15 yards? So basically, the football starts on the ground, kicks it, comes back. This is 22 yards later, or further, okay? It says the maximum height here would be 15. And just remember that the axis of symmetry is right between those two, and the x value for your vertex is the axis of symmetry, so that would be 11. So they give us a vertex, which is 11, 15. They also give us the zeros, which would be 0, 0, and 22, 0. All right, so given that they gave you the vertex and they gave you the x-intercept, you can choose whichever form you want. Okay, if you want to choose vertex, then you would say, well, this is our h and this is our k, and then we'd need to come up with a point. You could say this could be your x and y, or you could have this be your x and y. Doesn't matter. Probably be easier to use the zeros. If you wanted to use the intercept form, then you would want to say this is p and q, and this would be your x and your y. Okay, and you can't double count, so make sure you have unique a unique point that wasn't one of your key features. I'm going to use the vertex form, so h and k, and I'm going to use this as my x and y. So we'll do y equals a x minus h squared plus k. All right? Simplify this part. That gives you a negative 11 squared, which is 121. I'll subtract 15 from both sides. And then we'll divide both sides by 121. Okay, so that would end up being your a value. Okay? And then we would just need to graph. So we have our a, h, and k. So y is equal to negative 15 over 121, x minus 11 squared plus 15. Okay? And then it says enter your equation you found in your calculator. Look at the graph. Does the model the picture what you sketched? So you can always do this on your graphing calculator and make sure at least it looks like it's good. Okay? Is the maximum value 15 yards? Okay, so you could use second calc, find the maximum, and then make sure that's what you put in. What is the x value, time in seconds of the maximum? That should be 11. Okay? Sounds good. I was going to perhaps show you this app that I found for Apple, except when you look at it, it's going to be on its side. But this is called Calculate 84. This is what it looks like. The app looks like. Right here, it's pink. Calculate 84. Okay. So that works well with Apple, I think. You can always do stuff like that. So, like this was one of our first problems on our notes. You can plug that in, graph. You can do all the same stuff. So second, trace. Scroll up if you want to find the zeros or a value. So if you want to find an x-intercept, it says at the very top, it says left bound. So if we want to do left of that, push enter, right bound. And instead of having to guess, it just automatically does it. So that gives you a value. Okay. So the 0 is here. I guess you can't really see it, but it's not. It looks like it's not perfect. So our y sub 0 and so you can move all this stuff around, but it just says your 0 is negative 3.9999, which is negative 4. And then you realize that for the y-intercept, or for the x-intercept, y is 0, okay? So you can always look at that, see like it worked okay, and then you could possibly borrow one on the test that's actual TI-84, okay? Just make you sure if on the test you bring batteries in case you run out of juice, okay? All right, well, we'll see you later.